Hello and welcome to the video demonstration of the snow globe simulation project. My name is Felipe Hidalgo, and this project explores the development of a real-time snow globe simulation using position-based dynamics and particle-based techniques, built with TypeScript, WebGL, Three.js, and React 3 Fiber. The system combines Verlet Integration, spatial hashing, collision handling, and GPU instance rendering to simulate thousands of particles in real time, while supporting both marble and snow behaviors. This diagram here shows the main simulation pipeline. User interaction controls the globe, particles are updated using Verlet integration, and spatial hashing is used to efficiently find nearby neighbors. The constraint solver applies either marble or snow behavior. Collisions are resolved, and the final result is rendered using GPU instancing and physically based materials. In terms of the demo, you can access it here. You can open it online in a browser. As we saw before, everything starts with the user input. Using your mouse, you can click and drag the snow globe and alter the direction of the gravity, influencing particle movements accordingly. To talk a little bit about the particle system, the motion is calculated using Verlet integration and position-based dynamics in order to produce a stable real-time behavior. We use this to calculate the next particle's position based on the current position, the previous position, and the acceleration, that in this case will be the gravity. For the spatial hashing, we implemented grid cells, and this allowed us to calculate only the particles that we want or that are close to the current particle instead of calculating the collision to every single particle in the system. For constraint solver, it prevents particles from overlapping, and what this means is how does the particle react when it touches another. For this, we implemented two different solutions or particle types. We implemented marbles, that are the ones that we see here, or we can also change it to snow, that we will have a very distinct collision solver or constraint solver in this case. Then for collision handling, we implemented ellipsoids, as you can see here. If we enable the ellipsoids, we see all the different parameters or all the constraints where the balls cannot get inside, as we have the ground, we have the house, and the two trees. So what we're doing is, if a ball touches one of these constraints, we just retract it and it is repelled accordingly. Finally, we're doing GPU instance rendering, PBR materials, and HDR lighting, which are used efficiently to render thousands of particles in real time. Let's talk quickly about all the different settings that we have. If we reload the page, we would reset the settings accordingly. First, we can set up or we can up the mouse sensitivity to move the globe faster. Okay, let's keep it at 2 for now. For particle count, we can make it bigger, or we can generate up to 20,000 particles, but keep in mind this will affect performance. Let's keep it at 6,000. So as you can see, we generate or we render one single particle, and then through GPU instance rendering we create thousands of them. We can update the particle size. We can also change the velocity of the particles. We can make them move faster, etc. We can also change its type. We can set it to marbles. We can also set it to snow, and as you can see here, this is how snow will feel like within the snow globe. We also have different scene selections. We have the Christmas studio, but also snowy forest. We can show or hide the background, and at the end we can show or hide the ellipsoids. So that was the demo for the simulation rendering project. Hope you liked it. Thank you.